Okay, I'll open it up to you guys here. Anything, I'll do any constructions, any topics you want me to review. If not, I've selected a few questions, all right? Also, remember, the constructions are all up under that Regents Review folder on Aspen, okay? I don't know if I still have Aspen or not. No, I don't, so. Go ahead, Nate, start us off. Find a line of reflection? Okay, well, two different ways. One is through, we could do it using constructions. Okay. So you will algebraically. Okay, so here's what I'm going to do, because I do have one of those problems. So if you go in your packet, all the way to the end of your packet, if you guys go to question number 29 for me, in the review part at the end, I think this is what Nate's asking for. Okay, just so you can visualize it, 3, 2, 1, 2, 3, 2, there's point D. 7, -4, there's point D prime. Where's that line of reflection? All right, so I know it's going to look, just to get a visual of it, I know it's going to look something like that. What is that acting as, though? What's this another name for? Not even finding the line of equation for the line of reflection, but also finding the equation of the perpendicular bisector. Okay, because remember, if I connect D and D prime right now, if I connect D and D prime, the line of reflection bisects it and is perpendicular to it. So this is just another way of saying what's the perpendicular bisector. All right, ready? So there's two parts here. Let's talk about the perpendicular part first. Anybody want to find, we'll all find it together here, the slope of D prime. Because I need to know that slope to find the slope of my line of reflection. So the slope of D prime, up and over how many? Or you can use your slope formula. Let's see. On the y-axis, it looks like I'm going 6 units from -4 to 2. And on the x-axis, I'm going from 7 to 3, so I'm going 4 units. And is this a positive or negative slope? Little help, positive or negative? This is negative going downhill. I'm going to say halves. That's just the slope of D prime. So you guys tell me now, what's the slope of your line of reflection? -3/2. You guys know the relationship between the slopes of two perpendicular lines. It'll be positive 2/3. Flip it. All right, so there's the slope of the line of reflection. Now what I need is the y-intercept. All right, because here's the, right now, here's what I have for line of reflection. Y equals 2/3 x plus minus the b there. How do I find the b? Well, if it splits it in half, what's this point right here on D prime another name for? That's the midpoint of D prime, so that's what I need to find. So midpoint formula, add your x's, 7 plus 3, divide them by 2. Add your y's, -4 plus 2 divided by 2. End up with, let's see, 5. -2 divided by 2, -1. Does that look right? 5, -1. Yeah, it looks like in the ballpark. 5, -1. Look all right? Make any mistakes yet? All right. How do I use that to find the y-intercept for the line of reflection? Let's go, Todd, roll it. Plug it into y equals mx plus b. Here we go. What's the y coordinate I know it goes through? -1. Slope of my line of reflection. 2/3. X value. And then now I'm solving for b. No sympathy to you guys because everyone's got calculators that have your fraction templates, most of you anyway. So we end up -1 equals 10/3 plus b. Move the 10/3 over. Subtract 10/3 on both sides. Right in your calculator. I'd get practice at it now because you never know what it's going to look like tomorrow if this is a question on there tomorrow. And I believe, if I remember, my memory is correct, negative 13/3. Equal to the b value, where it crosses the y-axis. And then there it is, 2/3 x minus 13/3 for your line of reflection. Sorry I didn't provide that much room in there. Go ahead, Evan, what do you got for me? Well, there's a high chance that I could give you the pre-image, the line, find the image, yes, just like you guys had on your quiz, where you need to find the you need to define the equation of the segment. You knew the equation of the line of reflection. You have to find where they intersect, either set them equal or on your graphing calculator, and then do skip method with the midpoint. Yep, that's a high chance too. Nate, any more questions you wanted to add on here? All right, let me go back to the topics here. It's your call here all today, your call. Any of the constructions, anything with anything else up here, hey, we may want to go over that one more time. I forgot about that totally, or was having trouble with it. Skylar, let's go. Did you cut your hair again over break? Did you cut your hair again over break? Oh. What happened to the doing it yourself? Left it to the pros? Okay. It looks better. But go ahead. Say that again. It could be on the line, which means it stays the same line. So if I say, let's say I have this line right here. Here's a random point P on the line. I'd like you to dilate this line by 3 as P is your center of dilation. None of the points are going anywhere. Well, they are going anywhere. They are. Like this point here, if it's a dilation of 3, meaning it's going to get further away from P, but it's still going to be where? On the line. All right. This point here is going to get further away, but it's still going to be on the line. So the line doesn't change its equation. Mm-hmm. With a point that's not the origin and not on the line? Okay. I'm ready. I'm listening as I set this up. Yep. Around about the origin? Yep. Slope. Well, let's first talk about the origin. Slope's not going to change. Slope's not going to change. What is going to change is its y-intercept. So if I have, here you go, I'll just do this before I get to Scholar's question. Let's say I have y equals 3x minus 6. I want to dilate this by, go ahead, you pick 2, the origin. Okay, dilate it around the origin by 2. So the slope's not going to change itself. Okay, so it's still going to be y equals 3x minus 6. I mean 3x, but this point right here, 0, negative 6, that's going to change. To 0, negative 6 will change to 0, negative 12. So now the y-intercept becomes negative 12. Okay, slope won't change. All right, so not on the line and not the origin. Is that my question? Oh, I'll tell you where the point is. Yes, I will tell you where the point is. There's not going to be any assuming that tomorrow. I'll say around the origin or this other point. Okay. Next up.
Can you explain what point symmetry is?
Point symmetry. Yes, I can. By going to, that's another, yep, I'm going to go to 7. That's another one that involved point symmetry. Point symmetry. You rotate it 180 degrees and it's the same figure you started with. That's what a figure has point symmetry if you can rotate it 180 degrees, which is upside down to us. You rotate it upside down 180 degrees and it's the same figure. So up here, looks like there's only two letters up here that have, actually three, right? 3 letters that have point symmetry. Which letters up here, well, it's probably easier. Which one does not have point symmetry? T. You rotate T 180 degrees, you can do it right now on your paper, you're gonna get an upside down T. All right, so that does not have point symmetry. So I have the remaining ones up here. Which one has no line symmetry? S. Yep. So again, going back to your question, point symmetry, rotated 180 degrees, and it is its exact figure you started with. I'm Ellen. Or on the line? Maybe. Sure. Let's see, without giving you the actual one that may be on the test. Let's go. Point A is 2, 3. I'm going to make it easy because it's not that bad. Dilation of 2 around point P, which is, let's see, I'll go 4, 4. Okay, so here, I want to dilate. Now remember, we talked in class, what's dilation of 2 meaning? Is point A going to get closer to point P or further away? Further away, it's going to double its distance, and I say double its distance, but this would have nothing to do with the distance formula. All right, what I would do here, down and over how many? And then since it's 2, I'm going to do the same thing again. That will double its distance away. So whatever it is now, down and over that distance again. If I had 3, I do it again. If I had 1/2, I find the slope, cut it in half, get it closer. Okay, so just use slopes. All right, slopes instead. All right, and I'm not going to go anything crazy like a fourth or anything like that. Others, let's keep it going. These are great questions. Anything else? Haven't brought out the compass yet. Let's go, Stacy. What do you mean? Which number are we looking at? Number 3. Probably don't want the test to be brought up on everybody. There you go. There, it's going to be, there you go, 12 multiple choice if you're wondering right off the bat tomorrow. Okay, there you go. And I still didn't hear you, Stacy, because I got rattled because I opened up the test. Well, that's a construction then. You want me to do that one? Yeah, absolutely. So dilate through a scale factor of 2 through point P. You got it. All right. Okay, scale factor 2. Are all points getting further or closer to point P? Further or closer to point P if it's a dilation of 2? Further away, all right? Doubling its distance away. On the same side of P. Do not reflect it over P. This is not a reflection. Don't reflect it through P. So what I'm going to first find is, all right, well, what is that distance from, let's do point A first. What's that distance from point A? I want to double that distance. So I measure the distance with my compass from A to P. And again, I want to double that distance away, so I go on the other side of A and make a mark. And that's where point P prime would be. If I went a scale factor of 3, I'd do it another time. All right? And the same thing is going to go for D and B. I'm going to measure the distance from that point to P, and double that distance on the other side, double that distance, on the other side. What if I changed it up on you? What if I went 1/2? Now I want to get closer to P. How do I figure out where 1/2 the distance of PA is now? What construction do I have to perform now? Perpendicular bisector. So I need to go here to P, open it up more than halfway, and I'll do this one too. You'll never know what you see tomorrow. And then come on over here. Do the same thing. Line up your straight edge. It's not needed to draw the full line in. You just want to know where it intersects that line you originally drew in right there. And that's where P prime would be if the scale factor was 1/2. Getting closer to P. Good question so far. It's like you guys have some kind of advanced knowledge here. Yes, Rose, hello. What are we asking to do here? Rotate 90, you got it. We'll rotate one letter here. Okay. Before you start any construction tomorrow, get a visual of what it should look like at the end. Right now, clockwise or counterclockwise? Counterclockwise. So understand before you even touch compass to paper where point D, A, and B should be. Again, counterclockwise. All right, so A is moving around this way. D is moving around this way. B is moving around this way. Anybody have, actually, who asked, Rose, you got a preference of a point you want to rotate? A, you got it. All right, so I'm going to connect A to P. And again, I'm just visualizing I need to rotate it this direction 90 degrees. So I need to make a perpendicular line going through P. I need to make a 90-degree angle right here. All right, so this is what I need right here. So probably it would have been a good idea to do what with my line here? Extend it through P. And again, this is one way I'm going to show it. I believe when we went over this in class, I let you guys do this in groups, and there was another way some people found as well. I put my compass point on P, where I'm trying to draw that perpendicular line through. And I make an arc that intersects once, twice. From there, you can open up your compass a little wider, keep it the same. It's up to you. Go to each point of intersection, swing an arc, go to the other point of intersection, swing an arc. There you go. And now you should have your perpendicular line that you can draw through now. This is why it's important at the beginning to know where A prime should be, because look, you have actually two spots right now to put A prime. You could put it down here below the line, or you could put it above the line, but it's got to go counterclockwise. So it's got to go somewhere here. Other than angle measure, what else is preserved in a rotation other than angle measure? Distance. So that's my last part of the construction, making sure the distance from A to P is preserved. So there's the distance from A to P. I come down here. And again, I'm going up here now because it's got to be counterclockwise. That always happens, huh? Go back to your straight edge. Not the best, but make that arc, and there's A prime. Real quickly here, because this is a good question Rose brought up. Okay, that's 90. What if A prime were on here? How many degree rotation would that be? If I just measured the distance from here and copied it over here, that's a rotation of 180. And then think about it now. What if I copied the distance over here? That'd be a rotation of 270. So it really, hey, that degree measure doesn't make a difference to us. It's still the same construction. It's just whether I go 90, 180, or 270. Good question. Anything else? Let's keep its train rolling. Hello, Skylar. Reflecting over a line. Now, what are we talking about? Construction or algebraically? You got it. Which one? Page. Right here. Number 2. Got a point you want to reflect? Okay. When I put A prime over here, this is the first problem we went over today. What's this acting as again? A? Perpendicular bisector, right? So what I need is a perpendicular line coming from A that's going to be perpendicular to the line of reflection, right? Very similar to what we just did. I'm going to put my compass point on A. I'm going to make an arc that intersects twice, and looks like here I'm going to have to extend the line of reflection a little bit. No big deal. So I need a perpendicular line coming from A. Open up my compass a little wider. Go to each point of intersection. Grab your straight edge. And then distance is preserved. So the distance from A to your line of reflection. That distance right there is going to stay the same. So I hop on over and copy that over to the other side. And that's where A prime should be. Anything else here we want to touch upon? Feel free to ask, no big deal. Yes, ma'am. All right, we'll finish the constructions up now by doing a translation. I'll go to number 1 here. And I think well, now we actually haven't covered. We haven't covered everything. All right, translate along a vector. When you are, again, visualize where the triangle should be. A translation is a slide, not a reflection. It's going to slide in this direction of the vector, its length. So there should be nothing on the other side of the vector. Nothing on the other side of the vector. All right, should just be, everything should be up here. Got a point, Julia? B. All right, everyone ready? Well, it's got to slide the length of the vector, so I'm going to start this off by measuring the vector. All right, so I measure from the beginning of the vector to the tip of the vector. And if we're going to translate B, so I put my compass up to B. And I make a nice long arc because I know B prime's got to be somewhere on that arc. Somewhere. B prime's going to be located on there. Where is it going to be located? Here's the second step. I take the beginning of the vector to point B, that distance right there. From the end of the beginning of the vector to point B, and I copy that at the end of the vector. So go up to the tip of the vector. That's where your compass point is. And you've just found where B prime should be. Go ahead. So you have this first arc here, which is the length of the vector. Okay. Okay, once above, one below, yeah. But remember, too, where it should go. Remember, this is telling you where it should slide, right? So it's got to be here. It can't be down here because now I'm reflecting over the line. Good point. All right. Anything else? So I think the only thing construction-wise we haven't covered is how to find the line of reflection using a construction and how to find the center of rotation using construction. Those are the only 2 we haven't covered. Everything else is been covered here, so still got plenty of time though. Anything more here? Yes, Madeline. Center of rotation, yep. I'm going to have to make this. I don't think you guys have this one. I don't think I provided an example. No. All right, so I'll just have to make this one up. I have no idea if this is going to even work out. I don't know if I've rotated all the points properly, but okay, where to find the center of rotation? First thing I do is I connect a pre-image and an image. I do the perpendicular bisector for it. Okay, so I connect an image and a pre-image. I construct the perpendicular bisector for it. And then do it again for another pre-image and image point. So if you want to connect B and B prime here. So I do it again. Do another perpendicular bisector where those 2 perpendicular bisectors meet. That is the center of my rotation. Okay, so again, Connect two sets of pre-image and image points, do the perpendicular bisector for both, where they intersect is your center of rotation. Anybody know what I just did when you do it once? That's the line of reflection, yeah. Okay, so this one right here, I know this is not a reflection, but this would be the line of reflection for C and C prime. Yep. All right, so I think that covers everything now. Skylar? Rotational symmetry is rotated anything from 180 or less, and you get the original figure back. 180 or less. No. If a figure has rotational symmetry, because that would mean everything in the entire mathematical community would have rotational symmetry. What's that? No, that's incorrect. No. Because everything would have rotational symmetry then. No, between 0, the first rotation has to be between 0 and 180. Maybe let's put it this way. The minimum rotation has to be between 0 and 180. Like this right here where they show the square, it's got a rotational symmetry of 270. So maybe that's what it is by 0 to 360. But the first rotation, the minimal amount of degrees has to be between 0 and 180. If anything has point symmetry, it has rotational. Like the letter H, if you take the letter capital H here, what's the smallest amount of degrees I can rotate that and get H back? Okay, which means it has point symmetry, because points rotate at exactly 180 and you get it back. Rotational symmetry is rotate at 180, the minimum amount of degrees rotate at 180 or less. So this would have both point and rotational. Versus, here you go, not the greatest artist, I apologize. I don't even think I wanted to do that one. Yeah, I went this way. Assuming all triangles are congruent, I just drew here. This does not have point symmetry. If you rotate it 180 degrees, that's not the same figure I drew up here. Agreed? But rotational symmetry. All right. It has rotational symmetry of 360. How many times can I rotate this from 0 to 360 and get this figure back? So minimum amount of degrees, 120, which is we refer to as our magnitude. Okay, the order was how many times you could rotate it, which would be. So point symmetry, no point symmetry, both of them have rotational. We okay? Okay, Juliana.
Question number
3?
3.
Yep. Probably not. Let me go at the end of the packet now. 3, got it. If you're not comfortable turning your paper. Tomorrow you'll have as much graph paper as you need, yeah. Okay. If you're not comfortable rotating your paper and figuring out what the coordinates are after rotation, then I would suggest, yes, to memorize the rules for lowercase r is reflection, uppercase r is rotation, capital, there's 3 different ways to write a translation, and then you have capital D for dilation. Yep. Anything else here? Off the top of my head, Okay, so point P is the image after I translate it. So point P now would be, well, let's say 4. That's where point P is. So it's saying, all right, what else could I do to negative 3, 4 to get to 4, 3? And it looked like a rotation. Let's see if I can visualize this real quick. Nope, I got to go that way. I got to go this way, which would be what, negative 90? So it'd be 4, because I'd have to go clockwise to get it into the first quadrant. Okay. Anything else? A couple that nobody brought up that I definitely want to go over here. Go right to the proof at the proofs at the end. Number 33. We haven't mentioned this yet. I want to make sure our wording is correct tomorrow. All right, so I've graphed 2 triangles. Are they congruent to each other? Well, you have to write what's happening to get from ABC to DEF. What am I doing from ABC to DEF? Make sure you get specific. Just don't tell me translation. Just don't tell me reflection or rotation. Let's get specific. Anybody want to? This is a pretty easy one here, but what am I doing to go from ABC to DEF? Todd? Okay, so reflection over the y-axis. What do you know about reflections? Rigid motions that preserve distance and angle. So let's write it correctly. So yes, triangle DEF is a, what did we say, Saad, is a? How you going from here to here? Is a reflection over where? Over the y-axis of triangle ABC. So first tell me what's happening. Get specific. What's happening to go from one to the other? And maybe 2 of them tomorrow. Maybe it's a reflection followed by translation. You may have to do a sequence of them tomorrow. Now tell me what reflections are. Rigid motions that preserve distance and angle measure. And then you get to use whatever fancy word you want to try to impress people with. Thus, triangle ABC congruent to DEF. Again, tell me what's happening. Whatever's happening should be a rigid motion that preserves distance and angle measure. Quick last point here, unless anybody else has other questions. When you dilate, obviously distance isn't preserved, but what is? Angle measure. Corresponding angles do not change size when you dilate. Only the side measures do. Anything else questions-wise? Okay, with the time left then, you guys can work on some other questions in the packet. Ask me individual questions you didn't want to ask in front of people, whatever you prefer. And I'll be here until 2:30 today. If you have any quick questions to stop